It's a timely problem with pumpkin pie season. Imagine you're working as a process engineer and you're suspecting the dispenser for the pumpkin pie filling, and it may not be dispensing the correct weight of filling. The dispenser is supposed to dispense 200 grams of filling into each pie shell so that the pie bakes properly. A recent sampling using 15 pies has shown the average amount of filling in each pie shell is 199.2. If the population standard deviation is 1.1, is the pie dispenser out of spec? Use an alpha of 0.05. So if we can wrap our mind around what this problem is asking and the hints and the clues that it's giving us, you'll start to develop your ability to just kind of see through things. And obviously, we have a specification here. What's the specification? Just to get the elephant out of the room. 200 grams is the minimum weight, right? So we would say that is a lower specification limit. And we have a sample size of, what's our sample size? 15. The average of that sample size of 15, the X bar, is 199.2. So why don't we just say, well, it's out of spec. My average was lower than the specification. Like, what would you do if this was your scenario and you're like, well, I'm just making sure we're up to spec, and you get 199.2 out of a sample size of 15. So you can imagine if you're making pumpkin pies in a factory, 15 sample size, you're probably, in a given lot, you might be making 2,000 pumpkin pies, or maybe 200. So if we can put this into context, I always think about things in terms of circles. Like, let's say our our lot size, or our population is 2,000. In this case, we're taking a sample size of 15. And the specification for the lot is 200 grams. And we're trying to figure out what this parameter, why don't I just draw 15 dots? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 15 in there trying to represent the 2,000. So we're trying to ask the question, does this parameter, does that represent the lot? Do those 15 samples represent all 2,000? And the idea is we're going to make a decision. And we're going to use hypothesis testing to test the hypothesis that either that sample represents the population or it doesn't. And that's the difference between the null and the alternative hypothesis, which will sound familiar to some of you who have taken statistics. And you could just say, well, I'm not going to do any statistics. I'm going to reject the whole lot. But what if you actually, that was just kind of a bad sample? It wasn't a representative sample. It didn't represent all 2,000. You just kind of got a bad luck of the draw. So that's why today we're going to be looking at confidence intervals, and we'll get into the terminology, in which case the confidence interval for this one is going to be 95%, which is 1 minus alpha. So that you can, with confidence, start to make some decisions. In this case, the idea is, are we going to reject this lot?